Hey guys, my name is April, and I just want to take a moment to thank my mentor, Ted Stetz. Thank you for coming. The Rex managers as well, and my family for all their assistance and support throughout the program. Over the last 8 weeks, I've been helping collect data pertaining to the Boulder Creek, and my presentation is based on trends of ionic concentrations along the Boulder Creek. So, while home to a variety of wildlife, the Boulder Creek watershed is used for recreation as well as irrigation. The creek flows throughout the Boulder Canyon, and then across Boulder City, where it's subject to anthropogenic inputs. Primary concerns along the creek are runoff from urbanization and effluent additives from the Boulder's 75th Street wastewater treatment plant. This plant treats millions of gallons of water from our toilets, sinks, and storm drains daily, and it removes harmful organisms and other byproducts before it eventually combines with the Boulder Creek as effluent. On average, 17 million gallons of treated wastewater is discharged into the creek daily, and at some points during the years when the flow is low, the effluent can account for most of the stream flow. So in this study, we looked at concentrations of ions at 3 different sites along the creek. Our first site was Oradell, which is located a few miles up the Boulder Canyon. And this data covers September 2014 to June 2015. And I used this data to give us an idea of what the ion concentrations look like before they're subject to urban inputs. The next 2 sites are after the creek flows throughout Boulder at the 75th Street and 95th Street crossroads. Just after the 75th Street sampling site is where the wastewater treatment plant effluent combines with the Boulder Creek. So samples at these different sites were taken along the creek, allowing us to determine ion concentration at each site and how it fluctuates when it's subject to various inputs. So this research examines the concentration of sulfate, nitrate, and chloride along the Boulder Creek. We used discharge rates and ion concentrations in the study. Discharge rates were determined based on USGS gaugehouse readings. The gaugehouse records the flowing water every 15 minutes, and we use the daily average of those readings to show us an annual cycle of the river. Ion chromatography was used to determine the concentration of ions, and our samples were collected at each site in 1-liter bottles and filtered and preserved for analysis. So this figure here shows the annual discharge rate at the Oradell Gaugehouse and the comparison to chloride, sulfate, and nitrate. And you can see as the flow increases during the hot summer months when snow is melting from the mountains, the ion concentrations naturally decrease. So these graphs show the ion concentrations generally increase downstream. The green bar represents the Oradell Gaugehouse site. The yellow bar in the middle represents the 75th Street sampling site, and the orange bar represents the downstream site at 95th. Nitrate, you can see, increased substantially downstream, and chloride and sulfate concentrations also increased, but not as significantly. So effluent addition, phenology, and underlying geochemistry all play a role in the increase of ion concentrations along the creek. This figure shows our 2 sampling sites at 75th Street and 95th Street. The one on top is the 95th Street site. You can't see the color variations very well, but the bottom one is the 75th Street sampling site. We found that during low flow periods last September, from the 75th Street sampling site downstream to the 95th Street site, there was more of a 5,000% increase in nitrate concentrations. They increased from approximately 9 micromolars per liter to almost 500. Effluent addition may be cause for this. Further diversion of the creek downstream also slows the flow, making concentrations higher. And because nitrogen is a limiting factor in aquatic environments, these excess nutrients can lead to eutrophication and disruption of the aquatic ecosystems. Concentrations of sulfate and chloride also increase downstream. You can see a little better in this figure here. Gage House represents the 75th Street sampling site, and downstream represents the 95th Street site. So the wastewater treatment plant effluent could be cause for some of the increase. However, the underlying chemistry of rock formations play a major role. The Oradell Gage House site is underlined by granite rock, which is not as permeable as the sedimentary rock the two downstream sites are underlined by. We did see over a 300% increase in sulfate concentrations during low flow periods in September. But a gradual increase of these two ions suggests that geochemistry is the most likely factor. Sulfate is of concern in these environments due to sulfur's affinity to bind with heavy metals and increases an environment's susceptibility to heavy metal poisoning. And increases of chloride can increase salinity, and aquatic environments only have certain tolerance. So in conclusion, ion concentrations increase from upstream sites to the downstream sites, and when low flow conditions are present. Nitrate increased substantially over 5,000%, suggesting effluent input is reason for cause. But increases of sulfate and chloride are likely due to groundwater entering the creek. Future analysis may include observation of aquatic organisms within the environments to see specifically how increases are affecting them. Thank you.